Okay, so it is day 12 in Algebra 2, so it is Thursday, April 10th. I'm just going to write that on here. Thursday, April 10th. Okay, and for your do now today, I've given you 3 quadratic equations, and this time we're focusing just on finding the discriminant. I gave you that formula up at the top in case we forgot it. B squared minus 4 times A times C. And then we need to determine how many real solutions each of these problems will have. So let's start with number 1. I have x squared plus 4x plus 5 equals 0. And I want to find the discriminant. So how will I do that? What will the first thing I need to do be? Yeah, let's identify our A, our B, and our C. So I see my B is 4 and my C is 5, but I don't have a number for A. What is A? 1. Never a bad idea to remind ourselves of that. So we have 1, 4, and 5. So what will I do next? Perfect. We're going to plug the numbers into the formula. We have B squared minus 4 times A times C. So what goes in the squared position? 4. So I have 4 squared minus 4 times A times C. My A is 1, my C is 5. So I've got all of my values plugged in. Good morning. We're working on this at the front of the room if you want to grab a copy. So now that I have my A, B, and C plugged into the formula, where do I go from here? We're going to solve it. What should I start with? 4 squared. What is 4 times 4? 16. So I've got my 4 squared, that's 16. And the next part, I've got minus 4 times 1 times 5. Negative 20. So I need to write 16 minus 20. And what is 16 minus 20? Negative 4. So my discriminant, we'd say D equals negative 4. That is my discriminant. Now, before I ask you how many real solutions, let's just refresh ourselves on how we know how many solutions. When we find our discriminant, we have 3 options. You will either get a discriminant that is less than 0, or you'll get a negative answer, just like we did here. You'll get a discriminant that is equal to 0, meaning the number you get is literally 0. Or we'll get a discriminant that is greater than 0, meaning we get a positive answer. So how many solutions do we have whenever our discriminant is negative? None. No real solutions. And we can write that as 0RS. And I always like to put a slash through it. I don't know why, I just do. So there you go. That is our answer for number 1. Now before we do the other 2, how many real solutions do we have when the discriminant is 0? 1. 1 real solution. And last but not least, when it's positive, how many? 2. You'll get 2 real solutions, or 2 answers for x. Perfect. All right. Hey, Noel. Oh, thank you. All right. Now, before we do number 2, I would like somebody to come up with one question to ask me about number 1 that you think would help somebody who might be confused. Any question? Or do you think this is pretty straightforward? Do you think we're getting this? We're plugging numbers in. Based on the answer we get, we just follow the chart. It is fairly straightforward. However, if you are struggling with this, don't beat yourself up. Talk to me, tell me. I want to help, okay? This is tricky stuff, but you guys are doing great. So let's go ahead and look at number 2. Now I have x squared plus 2x plus 10 equals 0. What are my values for A, B, and C? Yes, A is 1. Since there's no number, we say it's 1. B is 2. C is 10. Perfect. So let's go ahead and use our discriminant formula. That's D equals B squared minus 4 times A times C. And I really like, when I'm using my formulas, I like to do this thing where I write out everything that doesn't change and I just leave blanks for what I'm putting in. I think that helps me not to get numbers mixed up. And if you are someone that struggles with mixing up your numbers, doing something like this I think can be really helpful. Okay, so what goes in my first blank? 2, my B. Second blank, 1, that's our A. And my last one, 10, C. Good. All right. Hi, Seth. We're working. Okay, so we have our values plugged into the discriminant formula. B squared minus 4 times A times C. So, what do I do first? 2 squared, which is 4. Now I've got minus 4 times 1 times 10. Negative 40. 4 minus 40 now is what? Negative 36. Perfect. So our discriminant is negative 36. How many real solutions are there? None. When the discriminant is less than 0, when it's negative, there are no real solutions. So I will write 0 real solutions. Perfect. Okay. Now let's look at our last problem, number 3. Now I have 5x squared minus 3x plus 2 equals 0. What are my A, B, and C?
5, -3.
Good. 5, -3, and 2. I'll just circle those. Okay. So same thing we did on the previous 2. We'll write the formula, leave some blanks. B squared minus 4 times A times C. What goes in my first blank? -3 for B. What goes in the next blank? 5 for A. And the last one, 2 for C. Good. Okay. What is -3 squared? Positive 9. Why is this negative number squared? How come we're getting a positive answer? Yes, 2 negatives, when you multiply them, turn into a positive. Just a quick refresher again. -3 squared just means -3 times -3. And that will give us positive 9. Okay, so I've done that part. Now I need -4 times 5 times 2. -4 times 5 is 20 times, yep, -40. Okay, So now I have 9 minus 40.
Negative 31.
Negative 31. So our discriminant is negative 31. And how many real solutions are there? None. All of these problems have given us no real solutions. So I'll just pull this out and let everybody see all the problems for a moment in case you missed anything. We were just finding the discriminant of each of these quadratic equations and then determining how many real solutions there were. And there's that guide. Okay. Now, if you need to see this after class, let me know. I'm happy to let you borrow it, make a copy of it. But today, what we are going to be talking about is something a little different. We are now looking at what happens when there are no real solutions. When we get a negative number as our discriminant, that means we're going to end up with a negative number under our square root symbol in the quadratic formula. And today we're going to talk about what happens when we get something like that. So I'm going to go ahead and pull this to the side, and I'm going to have this note page sitting right here on my side table. So if you were still looking at it, feel free to grab it and peek at it. But we're going to go ahead and start a page of notes. This is a very unnatural feeling lesson, and I would highly recommend making sure that you take good notes today. It's going to be a short and sweet one, though. There's no exit ticket today. It's Thursday. I like to take it easy on Thursdays, but this is a weird lesson, in my opinion. So I'm going to start by titling my notes, Algebra 2, Unit 1. You get to keep it since you were here and I saw you do it. Participation points are given, so you're good to go there. Okay, so we are still in Unit 1. Unit 1 is our longest unit. There's a lot that happens in this unit. And today is day 12, so we will write day 12 notes. Okay. And this is page 1. Okay. So today we are talking about imaginary numbers. I know. It sounds made up, but they actually exist. Imaginary numbers. Okay. So in most of the problems that we've been solving that are quadratic equations, we end up with either one answer or two answers, and our discriminant is usually always positive. The number that ends up under the square root is a positive number. But we're going to talk now about what happens when we get answers like these. We get negative answers for the discriminant, and that's going to end up giving us imaginary numbers. So the way that we write an imaginary number, or the way that we define it, would be the square root of negative 1 equals I. This is the very fancy, complicated symbol they came up with for imaginary numbers. The square root of a negative does not exist, so we say that it is imaginary. So let's talk about a few examples. If I, for example, have the square root of negative 36. First of all, when I find the square root of any number, what is it that I'm finding? What does it mean to find a square root?
The number multiplied by itself.
Yeah, it's what number can I multiply by itself to get to this number here. So if this was positive 36, the square root would be 6 because 6 times 6 is 36. You could also say that it's negative 6. If I want to find the square root of negative 36, what would your first guess be? What do you think maybe the answer might be?
You need a negative and a positive.
You would need a negative and a positive, but that's not the same number. So we can't do that. Some people might immediately think, well, positive 36, our square root is 6, so maybe negative 36, the square root will be negative 6, but it won't be, because negative 6 times negative 6 is positive 36. So we have to break this down before we can really find an answer. Negative 36, under the square root, we're going to say that it is actually equal to the square root of positive 36 times the square root of negative 1. Because we cannot find, there is no number that will multiply by itself to give you this negative 36. It's not possible. We need to separate the square root of negative 1 from the 36. So, since I just told you that the square root of negative 1 equals I, the way we would simplify this is, first we would find what is the square root of 36. And what is that? 6. So I would say the square root of 36 is 6. And the square root of negative 1 is equal to I. We call it I because it is imaginary, and we treat it just like a variable. That would be your answer. It's weird to wrap your mind around it.
This is might be an odd question,
Uh-huh.
but can it be written just like an I, or does it have to have the hook on it?
Ooh, that's a good question. I think it's probably a good idea to make the little hook on the I just because it might get mistaken for a 1 if it's a straight line. That's a good question. Not a weird question at all. Yeah, so the imaginary, the I, it's a good idea to make it have that little hook on it. It almost looks more like a J, but backwards. Just so that it doesn't get mixed up with a 1 if your dot on top is a little bit soft, you know. So, great question. But we would say the square root of negative 36 equals 6I. So really all you're doing is finding the square root of that positive number and sticking an I next to it. That's the only thing we do. So let's look at another one. What if now I wanted to find the square root of negative 49? I can't find the square root of a negative number. There is no number that when I multiply it by itself, it will never give me a negative answer. So we need to break this one up as well. Just like the problem above, how would I break up the square root of negative 49?
Equal square root of positive 49.
Yes, the square root of positive 49. And then that imaginary, yes, absolutely. So this second step, you can eventually will be able to just skip it. I'm showing it to you for the theory of it and making sure we know what's happening. But we'll say that we have positive 49 under a square root times, we're just going to get rid of that negative, times negative 1 equals Well, what's the square root of 49?
7.
7. And what's the square root of negative 1? I. We're just going to call it I. So our answer would be 7i. 7i. Let's do another one. How about the square root of negative 144? How would I break this up in my next step?
Positive 144.
We're going to do the square root of positive 144.
Times the square root of negative 1.
Perfect. Times the square root of negative 1.
Equals 12i.
Good. The square root of 144 is 12. The square root of negative 1 is imaginary. It's I. So 12i would be the answer. You guys seeing what's happening here? We're just finding the square root of the number and sticking an I next to it. That's all we do.
What if the number is not able to be broken down?
That's a great question. So, what if the number can't be broken down? Let's find one that can't be. For example, let's do the square root of negative 32. First, let's break it down like we did the others. Okay, so what would I do to get rid of the negative under the square root in my next step? Yes, we're going to write the square root of positive 32. Perfect, times the square root of negative 1. Now, whenever I try to find the square root of 32, let me see. I'm going to get a big, long decimal. 5.656854249, and it probably goes on forever. What we're going to do is we're going to take the number that we get and we're going to hold on to 2 decimal places. So I will take 5.6 and we'll round up to 6. 5.66. If you write 5.65, you won't get points taken off. I'm not grading you on your rounding abilities. But I'm going to say the square root of 32 is 5.66. And the square root of negative 1 is I. So you would do the exact same thing. You just won't get a nice, pretty whole number. All right. So there is 4 examples that we've just done together. And now I want to see if you guys can try a few on your own. So I'm going to write just a few problems and see how we can do. So I'll write try on your own. Okay. Let's do the square root of negative 121. The square root of negative, let's see, 45. The square root of negative 100. And I'm just going to put those 3 up here for now. So we want to do the square root of negative 121, the square root of negative 45, and the square root of negative 100. And if you are unsure what to do, check the examples we just did above. It's going to be the exact same process every single time. So I will pause this, and I want you guys to spend just a few minutes trying those on your own, and then we will check our answers. All right, so now we're going to go over the answers to these problems here. The square root of negative 121. What answers did y'all get? 11 I. Good. 11I is our answer. It's just the square root of 121, which is 11. And since it's negative, we put an I next to it. Now, is this color hard to see for anybody? If it is, I can change it. I just don't want anybody to be struggling. Okay. Number 2, the square root of negative 45. What answers did y'all get? 6.7. You either have 6.7, 6.70, 6.71. Those answers are all fine. All right, 6.71 I. 6.71 I. Perfect, perfect. Okay, and number 3, what's the square root of negative 100? 10I. Good. That is wonderful. Okay, guys. Good, good, good. So, we have now found all these on our own. I think y'all got this. Let's move forward a little bit. Now, before we do, did anybody get different answers? Or do we all got these? Heck yeah, that's good. Okay, so I'm going to go ahead and start a new page of notes. And we're going to refer back to the do now problems on this next page. I'm going to title it first though. Page 2. Algebra 2. It's day 12 notes. Continued. Okay. So we are now going to try to put these imaginary numbers in context. We are going to look at the answers we got on our do now, and we're going to use the discriminants to help us find the solutions to these problems. We know that there won't be any real solutions, so when there's no real solutions, there's actually still solutions, but they're imaginary. We're going to get 2 imaginary answers. So let's start by looking at our number 1. I'm just going to rewrite the problem and then copy down our discriminant. So number 1, we had x squared plus 4x plus 5 equals 0. And we found that our discriminant is negative 4. Now, in terms of the quadratic formula, the x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What is the discriminant in that formula? How could we describe it? Where does it go in the formula? Under the square root. Perfect. So instead of having to solve this all over again, we already have the number under the square root. It'll be negative 4. So I'm going to look at my a, b, and c again. My a was 1, my b was 4, and my c was 5. And now I want to write x equals my negative b plus or minus the square root of the discriminant all over 2 times a. Okay, so what will go in my first space? 4. That's my b, negative 4. Plus or minus the square root of what goes here? Negative 4. b squared minus 4ac. That's what goes under the square root. That's also the discriminant formula, so we already did it. It's negative 4. And then all of that's divided by 2 times what? 1. Our a is 1. Perfect. So we've got everything plugged in. And now let's simplify. I'm going to bring everything down. I have x equals negative sign in parentheses outside of 4. What does that become? Oh, so if it started as a negative and then there was a negative, it would become a positive. But since we started as a positive, that minus sign, that negative, will turn it into a negative. So we started positive, now there's a negative, it stays negative. When we start negative, the negative makes it positive. So it's whatever you start with, it'll be the opposite. So since we have negative outside of positive 4, it becomes negative 4. Okay, so we've got that. Then I'll copy plus or minus. And let's see. The square root of negative 4. What is that? 4i, almost. 2i. 2i, good. 2i. And again, all we did to get 2i, and I'll just write this as kind of a side note. The square root of negative 4 equals, it's just the square root of 4 times the square root of negative 1. The square root of 4 is 2. The square root of negative 1 is I. So that's how we got the 2i. Just like we did before. Okay, now what am I missing? All divided by 2. Perfect. Now, imaginary numbers are tricky to add and subtract with because we treat this I like it's a variable. It basically is a variable. It's like if I had negative 4 plus or minus 2x. Are these going to be like terms? No. So we are not going to be able to add them and subtract them. What we need to do instead is see if we can simplify this as if it were a fraction. So I have a 4, a 2, and a 2. Do these three numbers have anything that I could divide all of them by? 2. So what is negative 4 divided by 2? That'll be negative 2 plus or minus. Now, just like with variables, we can still take a number with an x on it, or in this case with an I on it, and divide it by a regular number. So I have 2i divided by 2, 1i. And 2 divided by 2? is 1. Now, just like any fraction, if I divide something by 1 like this, does it change the number? No, I can do any number divided by 1 and it won't change. So, for example, 5 divided by 1, it's 5. 12 divided by 1, it's 12. 20 divided by 1, it's 20. So -2 plus or minus 1i divided by 1. Do I need to write divided by 1? No, I don't. We can simplify it so that it is x equals -2 plus or minus 1i. And this is actually our answer because we can't go any further. This is what we call a complex number. And that's actually the mathematical term for it. It's called a complex number when you have a real number and an imaginary number. It is called complex. Now, this is the best answer, the most simplified answer that we can get. But do you think I would count it wrong if you left your answer like this? I won't. Do you think I would count it wrong even if you left your answer like this? I won't, okay? As much as it's great to know how to simplify fractions, that's not what I'm grading you on. I'm grading you on, can you get to the answer? It's okay if it's not simplified. I want to encourage you to try to simplify it, but if you get this far, that's correct. I will take it, okay? Now, that was a lot. Let's do another one. Let's do another one. That was a lot of steps. Let's look at number 2 on the do now. Where we have x squared plus 2x plus 10 equals 0. And on the do now, what was the discriminant that we found for number 2? -36. Perfect. So our discriminant was -36. So if I want to solve for what are my solutions, what are my x values, we're going to use the quadratic formula. Let's see. So I'm going to write out x equals -b plus or minus the square root of b squared minus 4ac, which is also the discriminant, all over 2 times a. Okay. Let's see. First off, I got ahead of myself. What are my values for A, B, and C again?
1, 2, 3.
Good. A is 1, B is 2, C is 10. So what goes in my first blank? 2. X equals -2b. Plus or minus the square root of what goes here? -36. Perfect. All over 2 times what? 1. Perfect. Okay. So we have x equals -2 plus or minus the square root of -36. All of that divided by 2. So now let's go a step further and simplify things. I'm going to go down to x equals, my b is +2, so my negative b will end up being what? Right here. -2. -2 plus or minus. Ooh, yes. -36. The square root of that is, I'm going to write the 6i down. It's just the square root of +36 times the square root of -1. So we go down from here. Square root of 36 is 6. The square root of -1 is I. And that's how we got there. And all of that divided by what? 2. Good. And we could stop here. This could be our answer. Hi, Lisa. But can I go any further? Can I simplify this?
Yeah.
I can. What can I do to simplify this? Yeah, we can divide everything by 2. So let's see. -2 divided by 2 will give me what? -1. Good. Plus or minus 6i divided by 2. 3i. And 2 divided by 2? 1. Do I need to write 1? No, I don't. I don't. So we're going to just leave it like that. This is our answer. Technically this is 2. So I'll circle them both. And I'm just going to write beside here, simplified. Divide by 2. Okay. All right, all right, all right. Do we have any questions about the last 2 problems we just did? Okay. Let's do that last one from the do now, and then we're going to take our break. And guys, honestly, after the break, I think I'm going to let you go, okay? I wanted to introduce this to you today, which we've done. We've introduced it. I'm not worried about y'all having this mastered yet. If you feel like you got it mastered, though, you're just ahead of the game, so that's great. So one more problem together, and then I'm going to set you free. Does anybody need to see this? And Lisa, I'm going to give you copies of these notes that you missed. Okay, let's go ahead and do one more. Now, you're welcome to stay if you want, but I can give you practice problems, but it's been a long week, so I will not have my feelings hurt if you all leave. I promise. So here's page 3. All right. So, last thing we'll do, last problem. Number 3 from the do now was 5x squared minus 3x plus 2 equals 0. And what was the discriminant that we found as our answer? Negative 31. So I'm going to just keep that out to the side. Okay. So I've got that in mind. Okay. So I'll go ahead and label my ABC just to remind me. My A is 5. My B is negative 3. My C is 2. So if I want to solve to find the solutions for this equation, what will I do next? Yes, x equals negative b plus or minus the square root of negative 31, our discriminant. I'll go ahead and stick that in. And it's all divided by 2 times a, which will be 5, yes. Okay, so what goes in our first blank for B? Negative 3. Now here's a case where our first number that we plugged in B to will be a positive, because we started with a negative 3 for B, so negative 3 goes in the blank, but with that negative outside of the blank, those 2 negatives will cancel, and now we'll have a positive answer outside. So what goes at the bottom? 5. Yeah. Okay, so let's start simplifying and rewriting. So I have x equals negative 3. What does that become? Positive 3. Okay, plus or minus
5.57.
Ooh, 5.57i. I'm going to double check it. I'm sure you're right. So, second square root, just to remind everybody how we do it, we hit the second button and the x squared button. That gives us our square root. I'm going to type 31. We get 5.57 if we round up. So 5.57, since there was a negative, it's 5.57i. Now, divided by 10. 2 times 5 is 10. Good. And off to the side, I'll just write how we got that. Square root of negative 31 is the same thing as the square root of 31 times the square root of negative 1. The square root of 31 was 5.57. The square root of negative 1 we write as I. And that's where we got that. Now, can I simplify this? I can't. So, this is our answer. 3 plus or minus 5.57i divided by 10. That's it. That is it. All right, guys. That is all we're going to do today. I just wanted to introduce this to you. If you know that you are missing any assignments, or you know that maybe you need to complete some things, come talk to me. I will be here during the rest of the period. Feel free to take a break before, but I'm here. If you feel good about our lesson today, you ready to go enjoy your weekend, go. You guys can leave. Yes. That's it. No exit ticket today. Everything that is due on Friday is written on the board. Tomorrow.